So our next setup is to change the factor surface area. So what we see here is 3 different sets of surface area with the same or similar mass. So in this case the reactant is calcium carbonate, and we can see that the mass of this chunk of calcium carbonate is 2.47 grams. The mass of these pieces of calcium carbonate is 2.48 grams, and the mass of this powder of calcium carbonate is also 2.48 grams, and the difference between the first, the second and the third is 0.01 grams, which we can explain in the evaluation. Laid out like this, you can see that the chunk and the surface area of the chunk is different from the pieces, is different from the powder. And if I were to describe the area or the space that the chunk, the pieces and the powder will take up, I can use this marker pen to show an approximate surface area. If I just go around the outside of where the calcium carbonate is lying on the piece of paper. Clearly you can see that the surface area of the chunk is less than the surface area of the pieces, which is also less than the surface area of the powder. So the learning point here is that surface area can change even though the mass is the same, and it depends on what you do with the reactant. In this case, this is a chunk. These are pieces that have been split up, and then this is a chunk that has been ground into powder. Now if I move from the idea of the surface area changing for the reactant calcium carbonate to how we are going to test that reaction occurring, the setup you're seeing here is 3 boiling tubes with 10 millilitres of acid in them. We are going to react the acid with the calcium carbonate, and we're going to time how long it takes for the calcium carbonate to no longer be visible. Another way of saying that more correctly chemically is we are going to wait until the reaction is complete between calcium carbonate and acid. So what I'm going to do is, as soon as I insert this chunk of calcium carbonate into the acid, I'm going to start the timer, and then 30 seconds later I'm going to add the pieces, and 30 seconds later I'm going to add the powder, and see which reacts the fastest by taking the start and the finish times for each of those. So here we go. You can see that the calcium carbonate chunk has been put into the acid. If you look very closely, and you may not see it, but you can see some bubbles of carbon dioxide being produced here. It's coming up on 30 seconds where I'm going to add my calcium carbonate pieces or chips into the acid, and you can see more clearly the reaction there of calcium carbon dioxide gas being produced. So in another 20 seconds now, I'm going to add the powder with the acid, and you will see the reaction. And you can see a really violent reaction in the production of carbon dioxide gas of powder surface area compared to pieces or chips compared to chunk. And if I go in a little bit closer, you may be able to see that more clearly still. We then stop the time. When the reaction is finished, the evidence of this would be we would observe no bubbles being formed any longer. If you see here, you can now see more clearly bubbles of carbon dioxide being produced from the calcium carbonate chunk. You can still see carbon dioxide gas being produced with calcium carbonate chips or pieces, and you can still see carbon dioxide gas being produced with bubbles in the reaction between the acid and the calcium carbonate powder.